Hi everyone, welcome to this video. We are going to develop today the exercises 7 to 13 of chapter 21. This is the chapter, The Theory of Consumer Choice. Remember, this is the book of Gregory Mankiw, Principles of Economics. So the first question says, a college student has two options for meals, eating at the dining hall for $6 per meal or eating a cup of soup for $1.50 per meal. Her weekly food budget is 60. A. Draw the budget constraint showing the trade-off between dining hall meals and cup of soup, assuming that she spends equal amounts on both goods. Draw an indifference curve showing the optimum choice. Label the optimum as point A. So the first suggestion is that we need to summarize all the information that the exercise provides us. So first, we have this one, which is the price of the dining hall, which is equal to 6 per meal. Then we have the price of cup of soup, from here just soup, 1.5. And here the income, which should be the budget of 60. So the first assumption in order to understand better the situation, we are going to imagine that all consumption is in soup. So this automatically brings that all your income over the price of the soup will bring you the quantity that you can consume of that good. Then 60 over 1.5, this will bring us 40. So then it means that if you spend all your money in soup, you can achieve 40 soups. Now imagine that you consume just a dining hall. Then you have the income over the price of the dining hall. Then you have 60 over 6. Then you can eat 10 times at dining hall. Then, in order to represent that the budget constraint, first we need to label the x's. I just labeled quantity of dining hall and the quantity of soup. Maybe I can make upside down. It doesn't matter. You can represent how you want. Then, here is the maximum point of dining hall. Here's the maximum point of 40. Then this should be the budget constraint. Remember, this line brings you all the bundles that you spent exactly 60. If you are here in this part, over this part, you will have down then 60. But if you are upside or above this budget constraint, you will spend more than 60. So this is the part. Then, summarizing the information, we have already this one. Now, this is your income. You know that the money that you spend in the dining hall, which is no more than the price times the quantity of the dining hall plus the price of soups times the quantity of soups, they will bring you your total spending, right? So then replacing, you know that income is equal to 60. Then you know that the price of the dining hall is 6. The quantity of dining hall that you will consume to maximize, or the optimum, given this condition that you spend equal amounts on both goods, then you don't know. Then 1.5 is given, then you have this one. Maybe you can think that this is just one equation with two variables. You know that this cannot be solved. However, we know another condition, that the quantity of the dining hall, the meals, are exactly equal of the quantity of soups. Then you can replace just Q and you can solve for a Q. Then you can sum these two. This will bring you 7.5. Then just for making a little bit order. So you have A equal to B, B equal to A, is exactly the same. You have this term 7.5 multiplying, so you can move to the other side dividing. So this should be the quantity. So this Q star is the optimum of the optimal quantities that you can consume given the condition that you spend the equal amounts on both goods. Then you have already this one plus the Q that we have already found. Then we have this one that we have already drawn, and here we have the condition. The Q of dining hall is exactly equal to the quantity of the soups. So this should be a representation of the indifference curve for normal goods, and this part should be the A1. This point, remember, where the slope of the budget constraint is exactly the same as the slope of the indifference curve, and this is the optimal for this student. Then B, suppose the price of a soup now rises to $2. Then, using your diagram from part A, show the consequences of this change in price. Assume that our student now spends only 30% of her income on dining hall meals. Label the new optimum as point B. Then this is the initial situation. But this one increases 30%. So naturally you just make sorry, this one, it's just like the price. This one moves to 2 because it's given for the exercise. Then we know already that this is the maximum. Now imagine that the spending on dining hall now spends only 30% of her income. Then you have the income, this is the spending, and dining hall, the quantities and the price. Then you know this one, I put here a label as 1 because this should be different from the previous situation. Then this one should be the other quantity. We have 60, which is the income, times the 30%, remember, is going to be the spending in a dining hall. Then you have 18, the price is already given, which is 6. Then this is multiplying, is go to the other side, dividing. Then the optimal quantity for dining hall should be 3. Then we know already that this is 60 because we have already 6, we have already 3 because we already found the price. The new price is this one, 1, so they should be this one, 2. With that information we can automatically find the quantity of soups in the second situation with a higher price of consumer of the soup, and with this fixed spending in dining hall. Then we have 6 times 3, 18. Then this is 18 is positive, it goes to the other side as negative. Then we have 60 over minus 18, so we have 32. We just move this one to this and this to this. It doesn't change anything, just for making the variable in the left side for order. Then we make this 2, which is multiplying, it goes to the other side dividing. Then we found that the quantity for the situation, the other situation, is 16. And in order to prove that this result, this makes sense, I propose that we can make this equation and we can replace all, and the results should be 60 because this is the budget. So then we have 6 times 3, then we have 2 times 16, then we end with the income of 60. So that should be okay. Then we are going to represent that in our graph. Here is the situation that we already found. Then we have the first situation, which is this one. We already knew that this was the optimal and the first part, and then this is the movement of the budget constraint. Why? Because the price of the dining hall, it doesn't change. So then if you consume or you devote all your budget to consumption for dining hall, you will finish with the same quantity. Otherwise, as the situation of the soup, because the soup increased the price from 1.5 to 2, so then now you need to divide all your income 60, not over 1.5 but over 2. Then you can just consume 30 soups instead of 40 due to the increase of the price. Then this is the second situation where the quantity of soups is equal to 16 and the quantity of dining hall is equal to 3. Then what happened to the quantity of cups of soup consumed as a result of this price change? What does the result say about the income and substitution effects? Explain. So then, this is the situation that we found previously. Then we know that the first situation, it was 8 and the other one was 3 for dining hall. So it was a decrease for the dining hall, right? For the soups, we had first 8 and then 16. So then it was an increase. So at the end of the day, you can say that for dining hall, the total effect is negative. However, for the situation of the soups, the total effect is positive because you increase the consumption. So this was the first difference curve, and this should be the second one, right? Then I'm going to split that effect for each good. First, I want to talk about the soups effect. So then, due to the increase of the price, naturally it was an income effect, a negative part. But it was a substitute effect, which was positive. So at the end of the day, we can infer that the soup was a total effect positive. So then this one was higher than the income effect. So for this reason, the total effect is positive. What about the dining hall effect? Due to the increase of the price of the other good, the income effect is positive because you need to consume more in this other good, and the substitution effect is negative. So then the total effect is less than 0. At the end of the day, the substitution effect is higher than the income effect. So for this reason, you consume more. You consume more in the other part, right? So then, that's the situation. D. Use points A and B to draw a demand curve for soup. What is this type of good called? Then this was what we found previously, right? Then this is the situation of the demand curve. Remember, in order to draw a demand curve, you need a y-axis, which is the price, and the x-axis, which is the quantities. And then for the first situation, for the price of 1.5, you have 8 quantities consumed, 8 soups. Then for the second price, which is 2, you will have 16 of consumption. So you just join these 2 points, and this is your demand curve, which is positive slope. This is slope positive, which is a strange for a demand. So this is what we called in economy given good. So this is a given good. When the price increases, the consumption increases as well. So next point. Consider your decision about how many hours to work. Draw your budget constraint assuming that you pay no taxes on your income. On the same diagram, draw another budget constraint assuming that you pay 15% tax. So then, This is your consumption and this is your hours of leisure. Why we make this representation? Because it's how we make throughout the chapter. So then this is your budget constraint. So you have two options. So you can consume or you can have more hours of leisure. And obviously, this is related with your wage and with your income. Because, for example, if your income is so high and you don't need to work so much, so maybe your consumption, this budget constraint should be higher than this one. Then, this is the situation when there is an increase of tax. So your hours of leisure, it doesn't change. However, your consumption will be lower due to this increase. So this should be the situation. Now, show how the tax might lead to more hours of work, fewer hours, or the same number of hours. Explain. So here it was the initial situation. So imagine that your allocation should be this optimal. And then this is the situation when the taxes increases or the taxes go to 15, then you will have less hour of leisure. It means automatically that you have more hours of work. And why it happened? We will go then to see that. Then the other situation is this one, when you have more time or leisure time. So then you work less hours. This is, remember, the income effect in that case is negative, but the substitution effect is positive because you replace consumption for, in this situation, the situation that should be compensated between these two. Then in this situation the income effect is negative and the substitution effect is positive, right? Then you will have this one, the income effect is higher than the substitution effect. So for this situation you have a decrease of leisure time or more hours of work. In the other situation is the opposite. The income effect is lower than the substitution effect, so for this reason the total effect is higher than 0. And the same numbers, this should be the case where the income effect is exactly equal to the substitution effect, so then the total effect is equal to 0. 9. Sarah is awake for 100 hours per week. Using one diagram, show Sarah's budget constraints if she earns 6 per hour, 8 per hour, and 10 per hour. Now draw indifference curves such that Sarah's labor supply curve is upward sloping when the wage is between 6 and 8 per hour, and backward sloping when the wage is between 8 and 10 per hour. So first, those are the three ranges of wages: 6, 8, 10. Then you have this representation where in the y-axis I put consumption, in the other part the hours of leisure. Then the maximum consumption, if you work all these 1 hour, 100 hours, then you will have 600. The other one should be, this should be the situation when these are those are the hours of leisure, and the other one should be 800, which should be 8 times 100 hours. Then the other one should be 1000. So naturally, when your wage increases, your budget constraint gets cheaper, but you can achieve more consumption. Then the other part says we already have this situation. Then this is the situation where first you have these hours of leisure. In the second situation, you work more, and then you have this situation. And then this third, that you work even more, and then you have this one. So then naturally this situation that you prefer to work more due to the increase of the price. Then if you can make the labor supply should be between the price of the salary, which should be the wage, and then L, that are the hours supplied. So for the first situation, you have 6 for the wages of 6, you offer or you supply this quantity. For the 8 is higher than 6, and for 10 higher than 8. So then this the situation where it's up upward sloping. Then the other situation is when we have this one, but on the other side, instead of working more, you start to work less. Then you have more leisure time. So then for the price of 6, you have this hour supply. Then for 8, less than 8, that 8 less than 6, and for 10 less than 8. Then this is the other situation. And the last one is like you exactly, I'm sorry, this one, the other question says, draw the indifference curve for someone deciding how to allocate time between work and leisure. Suppose the wage increases. Is it possible that the person's consumption would fall? Is it plausible? Discuss. So the hint is, think about income and substitution effect. So here is the situation where the wage increases. So naturally you have like more, your budget constraint move in the y-axis, and it gets cheaper. And then this is the situation where you consumption fall. And why? Then this could be the case that person consume less if this person naturally work less, right? And this person has more time. Then for the income effect is positive because this person is richer, but for the substitution effect, this person prefers more leisure. So then at the end of the day, in terms of consumption, the substitution effect is higher in absolute value than the income effect. So then the total effect for consumption is negative, is less than 0. Then consider a couple's decision about how many children to have. Assume that over a lifetime of a couple has 200,000 hours of time to either work or raise children. The wage is $10 per hour. Raising a child takes 20,000 hours of time. Draw the budget constraint showing the trade-off between lifetime consumption and the number of children. Ignore the fact that children come only in whole numbers. Show indifference curves and optimum choice. So then, the wage is equal to 10, and imagine that you devote all time in work. So then all consumption at that time should be equal to the hours times the wage. Then you have, as hours available, you have 200,000, and the wage is equal to 10. So naturally you can consume 2 million, right? So then imagine that you have all in children. This should be consumption in millions, should be 2 millions if you make all all you devote working. And the other situation in children, so you have 200,000, which is the hours available over the time that are demanded by children, 20,000. Then you will have 20. Then this should be the other part. So then should be the maximum numbers of children if you devote all time for children, and this one all time for working. Then suppose the wage increases to 12 per hour. Show how the budget constraint shifts using income and substitution effects. Discuss the impact of the change on the number of children and lifetime consumption. So here is the change from 10 to 12, and here is the situation. So here now, instead of 10 you have 12, so naturally you have more consumption. So for 2 to 2.4, then this should be the budget constraint. It increases naturally. then the situation should be the next. This one was the first, and this one is the other one, is the other indifference curve. Then here is the situation when you increase the raising more children. Then this is the first situation. So obviously you have an income effect because due to higher salary, couple are richer, so consume more. So income effect is higher than zero. And this is the substitution effect. Due to higher salary, couple can raise easier children. So for this reason, substitution effect, the situation interpreting that way should be higher than zero. So total effect is positive. Or you can think that the substitution effect is lower than zero, but at the end of the day, the income effect is higher than substitution effect. So at the end of the day, total effect is higher than zero. Or the other situation is that you raise few children. Due to higher salary, couple are richer, you consume more, and due to higher salary, they prefer use time for work instead of raising children. But this situation is substitution effect is lower than zero, and the substitution effect is higher than the income effect. So for this situation, the total effect is negative. So we observe that as societies get richer and wages rise, people typically have fewer children. Is this fact consistent with this model explained? Yes. This is the situation where what that we explained before. The substitution effect is negative, and this in absolute value is higher than the income effect. So for this situation, the total effect is negative. 12. Economist George Stigler once wrote that, according to consumer theory, if consumers don't buy less of a commodity when their incomes rise, they will surely buy less when the price of commodity rises. Explain this statement using the concepts of income and substitution effect. So here we have the commodity, the situation. Imagine that the income increases. So for this situation, naturally the consumption of both will increase. So the income effect is higher than zero, and the substitution effect in this case is equal to zero. So then the total effect is positive. The other situation is when the price of one commodity rises, just commodity 2 in that way. Sorry, this is not price. I'm sorry, price of commodity 1 rises. So this is the situation of the budget constraint. So as you can see here, the income effect is negative and the substitution effect is negative as well. So in that situation, we can see how consume will surely buy less when the price of commodity rises. So this is the situation of that explanation. The 13, 5 consumers have the following marginal utility of apples and pears. So here we have the quantities, the marginal utility. Remember, what is the meaning of marginal utility? Is the consumption provided, or the utility provided when you consume one additional good. So for example, in this situation, you have the marginal utility at certain point for apples and pears. You have for these 5 people, and this is the situation. Naturally, the higher utility for pears should be for Luke and Claire, and the higher marginal utility of apple should be for Claire and Phil and Hallie. Then, the price of an apple is 1, and the price of a pear is 2. Which, if any, of these consumers are optimizing over their choice of fruit? For those who are not, how should they change their spending? So remember, so here we have the price of apple, the price of pear. So we have 1 and 2. So the maximization condition is that the relationship between prices, which is PA over PP, it should be equal to the relationship and the marginal utilities. So then if that condition stays, you can conclude that those people, they are maximizing their consumption. So here we have Claire 1 over 2 and then 6 over 12. Naturally, this is exactly the same. So I would say that they are maximizing. Claire is okay. Phil is 1 over 2 equals 6 over 6. Then 1 over 2 is different to 1. What should be done to maximize? Then he can consume more apples. This one can consume more apples. So naturally, because of the low diminishing utility, then this marginal utility should decrease. So for this reason, this one should be the ideal should be 3. Then Phil can maximize. What about Holly? He has 1 over 2 equals 6 over 3, then different to 2. So then Holly, I recommend that he can consume fewer apples. So then he consume fewer apples. In that situation, until the maximum should be 12. And actually, I would say more per. Sorry, this should be not apple, should be per. So this should increase until 12. Then Alex, 1 over 2 is equal to 3 over 6. That's right, so he's maximizing. And Luke, he has this situation, so it's not the same. So he can consume more pairs until the marginal utility is equal to 6. Okay, so that was all for that video. I hope you have enjoyed and you have understood, and see you the next time. Bye bye.